Hello and welcome back everyone. This is a vintage car. It's a 1908 REO. But it's not my car and that's not me driving it. Actually, I'm more of a high booster bloke myself. This is a collaboration project with my friend Shane to make a replacement gear for this car. He has a new shed and the power is not yet fully connected. This is the finished gear. I thought it would be worth showing at the beginning of the video so you can see what we'll be making today. The gear is a TP8 with 62 teeth. It's 8 inches in diameter and it has 6 spokes with a hub, a 1 1/8 bore and a 3/16 keyway. The first thing needed is a pattern. This was made from an old gear which was then sent off to the foundry. 2 castings were made. The location of the gear can be seen in the cross section of the motor. The parts list shows the gear as part 3AA44 and it's noted as a large cam gear. This design has some challenges that will make machining this gear difficult. It's 200mm, that's 8 inches in diameter with a central boss of less than 50mm. The outer ring in which the teeth will be cut is supported by 6 spokes that are not exactly heavy duty. This will make holding the gear less secure than I would like. I'm not going to be able to cut this in a single or even in double passes. I'll start with a TPMN insert as the low rake is good for a bronze casting. The centre boss has a fair amount of wobble, so aligning the casting in the chuck is a compromise between the centre, which will be used to hold the gear during milling, and the outer ring which will receive the teeth. This will result in the boss being of a smaller diameter. The larger the boss, the higher will be the holding power of the chuck, but this is about as straight as a dog's hind leg, so I'll need to turn off a little more than I would like to get a suitable holding surface. I've set the casting up on a 4-jaw on the Colchester. I need the initial cuts to be deep enough to get under the harder casting skin. The riser used during casting has been broken off and ground, but it's left a scab which appears to be a little harder than the rest of the casting. I'll turn the reference surfaces, then change chucks. I'll mount a spindle adapter on the lathe so I can use a forge jaw that I can transfer to the divider. This will ensure the best concentricity between the teeth and the other turn features. It will also allow me to transfer the chuck with the casting between the mill and lathe at will. The adapter is a D13 to 1.5 by 8 TPI. It's designed to fit a BS1 divider. I have several other spindle adapters for this lathe that fit other machines and tooling. I have an interesting project coming up to make a spindle adapter for the big lathe. That will be a D18 to NT40. Keep a watch out for that video. I can now machine the outer ring and the teeth in the mill, then transfer the chuck back to the lathe and machine the bore, ensuring complete concentricity of the gear. The casting has been sandblasted so it's clean, and now I'm through the skin. I'll change to a TNGG insert to make the final cuts. The target diameter is 203.2, and that's what we have. The width of the ring is specified at 17.46mm. I'll machine it to around 20mm so I can bring it to final size and in the correct relationship to the hub after the teeth have been cut. These 2 pages of specifications were provided by Shane, and they show the technical details of the gear with calculations. The setup on the mill shows the issue with the small hub and the large outer ring. This is not a heavy duty chuck and it has limited holding power. Additional support will be required. The first task is to center the DRO as is normal practice for all divider operations. We'll proof mark the ring to confirm the setup. As the divider has a ratio of 40:1 and we need to cut 62 teeth, The divider will need a 20 hole progression on a 31 hole index plate. Yep, that's all good. The gear cutter is brought to centre height using a feeler gauge between the top of the gear and the cutter. Then a simple calculation determines how far the knee needs to be raised to achieve centre height. There are other methods of setting this, but this is the one we're using today. I mentioned earlier about the lack of structural strength in the casting. I'm using 2 angle plates to clamp the ring to provide more stability. One is clamped to the mill table and the other is used to clamp the outer ring to it to provide support for the gear close to the point of cutting. I've had this arbor for a while and never used it. Sounds to me like it isn't quite straight. The cutter is removing some metal on the return stroke, which also gives me the impression that it's dull. The second run is better, but I made a call to gash the gear before the final cut. Using a 2mm sling saw, I removed most of the waste between the teeth to reduce the load on the cutter for the final cuts. This has produced a burr on the exit of the cut, so I'll remove this in the Colchester. I reset the mill with a 4mm slitting saw to make a second gashing and remove more of the waste. I also bought a new arbor. For the final cuts we're using a different cutter, and again it needs to be reset for height. The cutter measures 9.5mm. Don't ask me why, it just did. The feeler gauge is a millimetre. The gear diameter is 203.2, so take half the diameter of the gear, which is 101.6, add the feeler gauge to get 102.6, then add half the cutter, which is 4.975, and that comes to 107.575. This is how much the table needs to be raised by. A touch off on the tooth crown and re-zero the y-axis and we're good to go. The first cut is made at a depth of 6.5mm and the setup is working well. The finishing cut is to the final depth of 6.98. It was a bit noisy and there was some vibration in the footage, and that made some of it unusable. The teeth look fine with some deburring needed. Mounting the chuck back in the Colchester, I'll finish the bore on one side of the gear. I'll rough the bore with drills, then take it to final size with the boring bar. I'm taking the drilling gently as bronze tends to grab the drill, and that's something I want to avoid. Since it's Shane's gear, he oversees the measuring.
It's 27. That's 27.53. So that's 28.51.
0.07 to go.
Yeah.
I like these 3-point micrometers. Be nice to have a set of them.
I'll call it. A bit more. That's it.
Where are we at?
Right, we're right.
We're good.
Yeah, all good. Don't take
It's
it.
come to size nicely and he's happy with the result. I can now remove the gear from the divider chuck and mount it into a spindle mounted chuck so I can hold the gear by the outer ring. The remaining features are not critical. Using a high-speed steel tool bit, I'll face the side of the gear and bring it to size. I'm using a high-speed steel tooling as it's a lot more forgiving on aggressive interrupted cuts. To achieve the dimensions specified, it's a simple 1.19mm offset needed on the DRO. A quick finish and rounding and this side of the gear is done. I've reversed the gear in the chuck and I'll part off the bias that was used for holding in the divider. Now that's gone, I can finish the hub to rough size before bringing the outer ring to its final dimension of 17.46. The DRO offset is 1.59 for this side of the boss. Before taking the gear out of the chuck, we'll cut the timing mark. The scribe will be from the middle of one tooth to the middle of the keyway. Well, that's the machining now complete, so it's off to the arbor press to cut the keyway. I refurbished this arbor press and made the stand for it in a previous video. If you'd like to watch this, I'll leave a link in the description.
recording.
The press is mounted on wheels so I can move it around the shed. I should bolt the bottom plate to the floor to give it more stability, and I would if I could find a permanent place for it.
I think that's it, Steve.
The edges are cleaned up with a file and my part is done. Shane took the gear to his shed and finished the clean up with a Dremel and a file. That sound you can hear is a police air wing helicopter flying overhead. The finished gear looks good and it's to specification and of a good finish. This project has not been without its challenges, but it's been a lot of fun. It's certainly the most difficult gear I've cut, but there have been some interesting learnings from it. The final photo shows the gear in assembly and in the engine casing. It fits perfectly and it's a great replacement for the original worn gear. It's fair to say that they don't make them like this anymore. This car was built in 1908. That's 118 years ago. It really is a work of art. Full kudos to Shane for his passion in old vehicles and his ability to restore them. This has been a great project build and an opportunity to share some time with a friend. Well, thanks for watching. I hope you liked this video, and if you did, please like the video. Be productive, be creative, but most importantly, be safe in your shed. I'll catch you next time.